right, we're going to look at section 2.4, which is Kirchhoff's laws. We're going to look at KCL and KVL. So one is Kirchhoff's voltage law, the other Kirchhoff's current law. Section 2.4, Kirchhoff's laws. So the first is, get this spelled right, Kirchhoff's current law. KCL. And very simply, it says the sum of the currents entering a node must be equal to the sum of the currents leaving. And that makes sense, right? So if a current is flowing into a node, it's got to go somewhere. It can't just disappear into thin air. So if we have some random node, and we have, let's draw 4 currents. We have some I1 flowing into this node. And I'll say I have I2 and I3 are both flowing out. And I4 is flowing in. The sum of the entering is equal to the sum of the leaving. So the sum of the entering equals the sum of the leaving. So I1 and I4 are entering. So I1 plus I4 is equal to I2 plus I3. Now another way we do this is to say that currents leaving a node are positive. So leaving a node is positive, entering a node is negative. And then the sum of that is equal to 0. That's the same thing, right? So if I say enterings are negative, that would just be moving these over to that side. So I have 0 equals I2 plus I3 minus I1 minus I4. Same exact equation. So this is the easiest to remember. Sum of the entering equal to sum of the leaving. But there are cases later, different techniques we use, that we're going to need to remember that entering currents are negative. So entering currents are negative. Just want you to get that down in your head. The second law is Kirchhoff's voltage law. So let's get lazy here and say K's voltage law. This is KVL. And KVL states that the algebraic sum of all voltages around a closed path or a loop is 0. Again, obviously, right? If I have voltage, if I have a positive voltage, then I need a negative voltage on the other side. Whatever is being supplied is being absorbed. So we want to treat a voltage drop as positive. Let me show you another way to think about this. So I'm going to draw 3 dummy elements here. Don't care what they are. And let's draw this one this way, and draw this one this way. V1, V2, V3. So a voltage drop is positive. This is a drop. I'm going from positive to negative, a drop. So that's a positive V. I'm going from negative to positive. This is a rise if I'm going around in a loop this way. So I'm going to draw that loop because it helps us with another technique later. So I'm going to go around this loop. When you're going around this loop, the sign you come to first is the sign you want to write down. That's the same thing as saying the rise is positive, the drop is negative. So if I come around here, come to the negative first. So I'm going to write minus V1. I come to this positive, plus V2. Keep going. I come to the negative, minus V3 equals 0. So that is the sum of the voltages equal to 0. That's Kirchhoff's voltage law. The book might show you these a little bit differently. And these are just kind of some shortcut techniques, some ways to think about how to do KVL and KCL. So you can watch the next video for some more example problems.